Ever opened like a million tabs and suddenly your computer slows down, like way slower than usual?
Wait, you mean slower than a snail in a staring contest?
Exactly. And it's like, what is going on behind the scenes to make it chug like that? Well, in today's deep dive, we're going to find out. We're taking on swapping. It's how your device juggles all the stuff it needs to keep in memory.
It's seriously like a juggling act. When you think about it, all those apps, all those tabs. Something's got to give eventually.
Yeah, and it's not like our devices have unlimited memory or anything.
Yeah.
So our source today was explaining how swapping is basically moving things around, like between the device's main memory and, get this, something called a backing store. What even IS? That sounds kind of shady.
Well, it's not as shady as it sounds. Haha. Think of it more like, temporary storage. Yeah, like on your hard drive or SSD. The source mentioned how they used to do this thing called standard swapping. Can you imagine?
Oh man, the source made it sound awful.
Yeah.
Like they were moving an entire program every time between the memory and that storage area. Talk about a traffic jam.
Right. Imagine if we had to rearrange an entire library book by book every time we needed something. Thankfully, it's way more efficient than that now. They've got the system called swapping with paging.
Paging. Okay, that sounds a little less archaic. But I can only imagine how much more complex that must be. How does the system keep track of all those little bits of data?
It's really quite incredible when you think about it. So instead of moving that entire program, the system swaps out individual pages of data, smaller chunks, quicker transfers.
And this is happening constantly in the background. Oh my gosh, I'm suddenly very aware of all the tabs I have open.
Yeah, it really makes you think twice about leaving that many tabs open, huh? It's like, imagine if your phone tried to swap out chunks of all those web pages every time it ran out of active memory.
Oh, my phone would probably just spontaneously combust. I mean, I know I've had my share of slowdowns, but it's never quite as bad as my old laptop.
See, that's because your phone, iOS, and Android, all those mobile operating systems, they have to play by different rules.
Yeah, our source mentioned that. Something about flash memory, right?
Exactly. They can't rely on swapping as much because of the type of storage they use, that flash memory.
I have to admit, I don't totally get that. I always thought flash memory was supposed to be like the good stuff.
Yeah.
Smaller, faster, all that.
It is fast? Oh, yeah. But there's a trade-off. Flash memory has a limited lifespan for writing data. They call it write endurance.
Right, endurance.
Yeah.
Okay, so what happens when it runs out of endurance? Does my phone just give up?
Thankfully not. iOS and Android, they've come up with some pretty clever workarounds to avoid too much swapping. iOS is more like, hey, can you maybe, it politely asks apps to free up some space.
And if they don't, what happens then?
Well, let's just say it's got ways of encouraging them. Android's a little different. It's more proactive. Like, it'll save the state of an app to flash memory before it becomes a problem.
Oh, that's smart, so it can just kind of pick up where it left off.
Exactly. So when you reopen it, it's like nothing even happened. Seamless.
I gotta hand it to those developers. That is pretty elegant. All this talk about limited memory on my phone, though, it makes me think, is this related to virtual memory? I feel like I hear that term thrown around a lot with computers.
You're connecting the dots. That's a perfect segue, actually.
Virtual memory. Is it like some secret stash of RAM my computer's got hiding? Like a little bonus it doesn't want to tell me about.
Haha, I would. No, but it is a clever trick. Remember how we were talking about swapping and it uses your hard drive as that temporary storage space? Well, virtual memory takes that idea and kind of supersizes it.
Supersize. How do you supersize memory?
Yeah.
Is it like magically creating more RAM out of thin air?
Not magically, but it does create this illusion of having way more RAM than you actually do. Okay, so picture this. Instead of just swapping out entire programs or even just pages, virtual memory lets the system use a way bigger range of memory addresses than what physically exists even.
Hold on, I need to wrap my head around this. So it's like telling everyone your tiny apartment is actually a mansion by like rearranging the furniture really cleverly.
You've got it. And when your computer needs something from this mansion, something that's not in the actual RAM, it uses part of your hard drive or SSD to store it and go get it when it needs to. Like a super speedy delivery service between your main workspace and a giant warehouse.
Okay, yeah, that makes more sense. So swapping is a vital part of how virtual memory even works then.
100%. It's all about swapping those pages in and out from that secondary storage. That's how it creates that seamless experience, But here's the thing. Even though it makes your digital life way smoother, it's not a perfect system. Just like too much swapping can slow things down, if your computer's relying too heavily on virtual memory, that can cause problems too. Bottlenecks, slowdowns, you name it.
So if I'm constantly seeing virtual memory kicking in on my computer, That's a sign I need to think about upgrading my RAM. Or maybe, like, close some of those memory hogging applications I have running.
Ding, ding, ding. It's your computer's way of saying, hey, I'm trying to work here, but I could use a little help. And this whole discussion reminded me, even those clever mobile operating system with their workarounds and everything, they use a form of virtual memory too.
Oh, right, with those limitations on flash memory. But they still got to manage all those apps and all that data somehow.
Right, and it shows you how far these systems have come. It's pretty elegant how they create that illusion of having plenty of memory, even with those constraints. And it all comes back to managing those limited resources, just like we were talking about.
So to wrap it all up for our listeners, besides the fact that our devices are basically playing memory Tetris behind the scenes, what's the key takeaway?
I think the most important thing is to be aware. Think about that invisible workload your devices are handling. Whether it's swapping or this virtual memory magic, it's not unlimited. Understanding how it all works, that's power. It helps you make smarter decisions about how you use your tech and when it might be time for an upgrade.
And hey, maybe you can impress your friends with all your memory management knowledge. But on that note, I think it's time for us to swap out of this conversation for something new. Thanks for joining us for today's deep dive into swapping and virtual memory. Catch you next time.